Welcome to The Explainer. Today, we're going to pull back the curtain on your body's most sophisticated defense force, its very own elite intelligence agency, the adaptive immune system.
All right, let's just jump right in with a puzzle. Every single day, your body protects you from brand new threats, pathogens it has literally never seen before. So how on earth does it do that?
Well, it's all because your body is running two security systems at the same time. You've got your first responders, that's your innate immunity. They're fast, they're hardwired, but they only recognize common criminals. And then you've got the elite specialists, your adaptive immunity. These are the spies and secret agents called in for the new, the dangerous, the totally unknown threats. So imagine a new virus appears, something like SARS-CoV-2. The first responders, well, they're completely blindsided. Their rulebook has no entry for this new guy. They get overwhelmed, and that triggers a system-wide alarm. It's a call for help, a call for the specialists.
So, that alarm, that's the signal to call in the adaptive immune system. And we're not talking about just a few cells here. We're talking about a massive, sprawling network of specialist agents called lymphocytes.
And here's where things get just wow. The scale of this operation is absolutely mind-boggling. Your body can generate up to 1 trillion different types of receptors. That is a unique lock for pretty much any key, any possible enemy shape you can imagine. It's prepared for anything.
Now, this whole agency basically has two kinds of operatives, two main specialists on the payroll. You've got your B cells, who are like the trackers, and you've got your T cells, who are the commanders running the show on the battlefield.
Okay, so let's start with the B cells, the trackers. Their mission is direct, it is brutally effective, and it's all about finding the enemy out in the open.
These B cells are constantly patrolling your body's fluids, your blood, your lymph, and when one of these trackers finds a pathogen that perfectly fits its unique receptor, it's like a key snapping into a lock. That's the signal. The B cell activates and boom, it starts cloning itself, building a massive army of identical soldiers.
These clones become tiny weapons factories, just churning out millions of these proteins called antibodies. You should think of them as precision-guided smart missiles. Now, they don't actually kill the enemy themselves. Instead, they swarm the pathogen, latch on, and basically paint a target on it, making it super easy for other immune cells to find and destroy.
Okay, that's great for enemies floating around out in the open. But what about the really clever ones? I'm talking about viruses. Their whole game is to hijack our own cells and hide inside. So this is the big problem for T cells. How do you fight an enemy you can't even see? Because it's hiding inside your own headquarters.
Well, to solve this, the system has these incredible scout cells, called dendritic cells, and you can really think of them as the agency's interrogators. Their whole job is to patrol the front lines, capture any suspicious characters, and then break them down to gather intelligence.
And this is the really important part. For the dendritic cell, destruction is secondary. Its main goal is intelligence gathering. It literally dismantles the bad guy into little protein fragments called peptides. This is the raw intel that T cells need.
So where does this intel go? It gets presented on these special platforms on the cell surface called MHC molecules. They act like little display cases, constantly showing passing T cell commanders what's going on inside the cell. It's a nonstop, real-time status report.
Right, and here's the crucial twist. It turns out there are two different kinds of these intel platforms, these MHC molecules, and the type of platform that's used for the briefing determines the commander's orders and the entire strategy for the war.
This breaks it down perfectly. On one hand, if the intel comes from an enemy found outside a cell, it's presented on a Class 2 platform. That activates a helper T cell, which is basically a general who coordinates the entire army. On the other hand, if the intel reveals a spy operating inside one of your own cells, it's shown on a Class 1 platform, and that activates a killer T cell who gets one single command: destroy this compromised cell now.
And get this isn't just happening in a few places, it's happening everywhere. Pretty much every cell in your body with a nucleus has these Class 1 platforms. They're constantly holding up little pieces of what they're making on the inside, almost like showing an ID card, proving to passing T cells, hey, I'm one of the good guys, or raising the alarm that they've been hijacked.
Okay, so once the right commanders, the helpers and the killers, get their orders, the tide of the battle turns. The war is won through a highly coordinated, devastatingly effective attack.
The helper T cells act like generals on the field, directing the B cells to crank up that antibody production to mop up any viruses still floating around.
And at the exact same time, the killer T cells are hunting down and eliminating the infected cells one by one, shutting down the enemy's factories for good.
But wait, winning the battle isn't even the end of the story. This is where the adaptive system shows its real genius. It never, ever forgets an enemy. After the fight, a few of those specialist B and T cells that were so effective, they stick around. They become memory cells.
This right here is the very definition of immunity. It's why you only get chickenpox once. The first time you get sick, the response is slow. It takes days, maybe weeks, to build up that custom army. But the second time that virus shows up, even years later, those memory cells are ready. They launch a response that is so fast and so powerful, the invasion is crushed, often before you even feel a single symptom.
And that leaves us with this incredible, powerful idea. If this amazing intelligence agency inside of us can learn from an attack and create a permanent memory of the enemy, what if we could give it the intel it needs before the real invasion even begins? What if we could train it? Well, understanding that is the key to one of modern medicine's absolute greatest achievements.